explore relations, domain, and range. Let's begin with an example. Here we have two sets. First, on the left, we have a set of students, and on the right, we have a set of classes. Let's think of ways we can relate students with classes. One way is to associate students with the classes they're taking. Here, we have John taking English and history, Jane taking math, and Michael taking chemistry. So this is an example of a relation between students and classes. Let's take a look at this relation. We see that John is associated with not one, but two classes. In mathematics, we're interested in certain relations. These are called functions. Here's the definition of a function. It's not just any relation. Functions want to avoid relations like these. We don't want an element, a student here, to be associated with more than one class. So a function does that by requiring that each little x, each element, that is, of capital X is associated with exactly one element, capital Y. Let me underline that. Exactly one. So this relation here, the example, is not a function. So when we have a function, this set capital X, the first set, is called the domain. So if we have little x associated with little y, little x is called the input, and little y the output. One more. The range is the set of all outputs. Let's do another example. Does this relation represent a function? We can picture this as a mapping. In the first set, we'll put down the first coordinates of all the ordered pairs. Negative 4, 2, 3, 9, and positive 4. And in the second set on the right here, we'll put down all the second coordinates that occur in these ordered pairs. 6 and positive 9. That's it. So This relation associates negative 4 with 6, but not 9. It associates 2 with 9, but not 6. It associates 3 with 9, 9 with 9, and 4 with 9. So is this a function or not? Yes, it is. If you just look right here, you see that each element in this left set has exactly one arrow emanating from it. Let's do another example. Let's take this equation. We want to know whether it defines y as a function of x. So when we look at all of the solutions to this equation, what we want to know is whether it's true that each value of x has exactly one value of y associated with it. Exactly one. Let's try to solve this equation for y. This equation is equivalent to y equals plus or minus the square root of x. So we see that for example 4, square root of 4 is 2. That 4 has exactly 2 values of y associated to it. So this does not define y as a function of x.